Information Systems Development, ISD, is a comprehensive process that involves the creation, implementation, and maintenance of information systems to meet organizational needs. This extensive guide delves into the various facets of ISD, including methodologies, life cycle stages, tools, and best practices, providing a thorough understanding for both novices and professionals in the field. Information Systems Development, ISD, refers to the process of creating and maintaining information systems that support organizational functions and decision-making processes. These systems integrate hardware, software, data, procedures, and people to collect, process, and distribute information. The primary goal of ISD is to develop systems that align with organizational objectives and enhance efficiency and effectiveness. The evolution of ISD has been marked by significant milestones. 1960s, introduction of the Systems Development Lifecycle, SDLC, a structured approach to managing large-scale software projects. 1970s to 1980s, emergence of alternative methodologies such as rapid application development, RAD, and prototyping to address the limitations of traditional SDLC. 1990s, adoption of object-oriented analysis and design, OO8 methodologies, emphasizing modularity and reusability. 2000s present, rise of agile methodologies focusing on iterative development, customer collaboration, and flexibility. Systems Development Lifecycle, SDLC. The SDLC is a traditional framework that outlines the stages involved in the development of information systems. Planning. Define the project scope, objectives, and feasibility. Analysis. Gather and analyze business requirements and user needs. Design. Develop system architecture, data models, and interface designs. Implementation. Translate designs into executable code and integrate system components. Testing. Conduct various tests to ensure system functionality and performance. Deployment. Install the system in the production environment and provide user training. Maintenance. Perform ongoing support, updates, and enhancements. This linear approach, often referred to as the waterfall model, is suitable for projects with well-defined requirements. Alternative development methodologies. To address the limitations of the traditional SDLC, several alternative methodologies have been developed. Agile development emphasizes iterative progress, customer collaboration, and adaptability to changing requirements. Rapid application development focuses on quick development through prototyping and user feedback. DevOps integrates development and operations to enhance collaboration and efficiency in deploying applications. Scrum, a subset of Agile, utilizing short development cycles called sprints to deliver incremental improvements. Extreme Programming, XP, advocates for frequent releases in short development cycles, enhancing productivity and introducing checkpoints for adopting new customer requirements. Each methodology offers unique advantages and is selected based on project complexity, organizational culture, and specific requirements. Requirements gathering and analysis. Accurate requirements gathering is critical to the success of an information system. Techniques include interviews, engaging stakeholders to understand their needs and expectations, surveys and questionnaires, collecting data from a larger audience to identify common requirements, observation, studying current processes to identify inefficiencies and areas for improvement, document analysis, reviewing existing documentation to understand current system functionalities. Once gathered, requirements are analyzed to determine feasibility, prioritize features, and establish a clear scope for the project. System design. The design phase translates requirements into detailed specifications. Architectural design defines the overall system structure, including hardware and software components. Data modeling creates data flow diagrams and entity relationship models to represent data relationships. Interface design develops user interfaces that are intuitive and user-friendly. Security design incorporates security measures to protect data integrity and confidentiality. These designs serve as blueprints for the implementation phase. Implementation and coding. During implementation, developers write code to build the system components.